Welcome back. In this video, we're going to try to prove that the product of the cosine of x over 2k, 2 to the power k, with k going from 1 to n is sine of x over 2 to the power n sine of x over 2 to the power n. We're going to use induction to prove this result. And we're going to use the half angle formula to help us find or check this result. In fact, this result is coming from the half angle formula repeated over and over again. Okay, but now we want to prove it just using the principle of mathematical induction. To do that, so let's call P of n the statement that the product, okay, going from 1 to n of cosine of x over 2 to the power k is sine of x over 2 to the power n sine of x over 2 to the power n. Okay? First, we're going to prove that P of 1 is true. We're going to assume that this statement is true for n, and we're going to prove that it's true for n plus 1. And after that, we're going to deduce that the result is true for all n bigger than 1, n positive integers. Okay, so P of 1 is what? It's just the cosine of x over 2 equal sine of x over 2 sine of x over 2 sine of x over 2. So using the half angle formula, we know that sine of x is 2 sine of x over 2, the cosine of x over 2. Okay, if we assume that the sine of x over 2 it's never 0, and we divide, we're gonna get sine of x over 2 sine of x over 2 is just the cosine of x over 2. Therefore, P of 1 is true. This statement is true for n equals 1. Okay, next what we're gonna do is we're gonna assume that P of n, this is the induction hypothesis. So the product, okay, going from 1 to n of the cosine of x over 2 to the power k is equal to sine of x over 2 to the power n sine of x over 2 to the power n is true. So this is the induction hypothesis. It's true for some n that we fix, and we want to prove that P of n plus 1 is true. Okay, so when we get here, we want to link the induction hypothesis with the P of n plus 1. So we assume this is true, okay, and we want to prove P of n plus 1. It's good to write the expression of P n plus 1. So this is what we want to prove. So k will go from 1 to n plus 1 of the cosine of x over 2 to the power k, and it must equal sine of x over 2 to the power n plus 1 sine of x over 2 to the power n plus 1. So this is what we have to prove. Okay? So the left side, we can easily get that. How? So we assume that this is true. Okay? So if we multiply by the cosine of x over 2 to n plus 1. Okay? So here, so k going from 1 to n, cosine of x over 2 to the power k times the cosine of x over 2 to the power n plus 1. What's this one here? This is another way of writing it as k going from 1 to n plus 1 of cosine of x over 2 to the power k. Okay? And we have this one because we know that given that a equals b. So if we assume this is a, this is b, if we multiply both sides by c, nothing is going to change. Our c in this case is it's cosine of x over 2 to the power n plus 1. Okay, so the left side is this one here. So this is our left side that we want to prove. Okay, now we need to prove that the right side can be written in this way. Okay, so we have the induction hypothesis. So we have sine x over 2 to the power n sine of x over 2 to the power n times the cosine of x over 2 to the power n plus 1. Okay, because we multiplied everything by the cosine of x over 2 to the power n plus 1. Okay, so now we have to write this one here in this form here. How can we do that? We're going to use the half angle formula here. Okay, so the half angle formula is going to give us what? It's going to give us 2 sine of x over, we divide this by 2, it's going to be 2 to n plus 1 cosine of x over 2 to the power n plus 1. Okay, and once we have that, this one will go with this one, and 2 times 2 to n to the power n is going to give us, let me write it down in fact, so it's going to be, this one will equal sine of x over 2 to the power n plus 1 times this one here, sine of x over 2 to the power n plus 1. This one is gone because we switched this one by this product. Therefore, we see that that p of n plus 1 is true. Okay, so here instead of n we have n plus 1. Look here, and this means that we have proved the result. Okay, therefore we can say, using based on the principle of mathematical induction, that p of 1 is true. We assume that p of n is true, and we prove that p of n plus 1 is true. Therefore, this result is true for all n's bigger than 1. Okay, so we have this result that's going to help us a lot in dealing with infinite products, or maybe we can play with x here. Okay, we're going to see that with this x we're going to get a lot of results. Okay, so I think that's all we need to do. If you see any errors or mistakes, please let me know. Thank you very much.